Dear St. Joseph's International School students of Primary 6, in this video we continue what we have started in explaining Primary 6 science curriculum. And in the last video, you remember we were talking about thermal energy and matter. So we continue talking about this in today's video, but first we try to memorize or to remember what we have learned in the last video and in the last few lessons. So let's try and answer these questions. As usual, you pause, answer, and check your answer after you continue the video. So let's try question 1. True or false? When we heat solid matter, it freezes. Is that true or false? That's of course false, because it melts, not freezes. Good. Question number 2. Condensation is the change of gas state, the change from gas state to liquid state. Is that true or false? Well, that's true. So condensation is when a gaseous state matter changes into liquid. Good. So let's talk more about how these changes between different states of matter can happen or can take place. Well, we remember that we have 3 states of matter, right? And the first one is solid, and the solid has what? Do you remember? It has the least amount of thermal energy. And to increase the thermal energy, you increase the temperature. So as we go up, you can see the temperature increasing. So here we have a solid, and as we increase the temperature, you can see that it's moving more towards being liquid until it reaches a certain point which is called the melting point. And it takes some time to melt, and this is what we call the area of melting. Once it's molten, we can see that it's become liquid. And as we increase the temperature one more time, the liquid, you can see it becoming more gas. So the liquid is heated until it reaches the boiling point. So the boiling point is a certain temperature. And it takes some time to evaporate, and this is what we call the area of evaporation, until it becomes gas. And here, as you keep increasing this distance between the molecules, the distance between the particles increases, the movement increases, they become faster, and so on. So in area 1, the matter is solid, and it has low thermal and kinetic energy. In area 2, now the matter is melting, so it's becoming liquid. So what is the melting point? It's the temperature at which matter changes from solid to liquid. So it's a specific temperature, and at this temperature, matter changes from solid to liquid. Good. But what is the boiling point? It's also a temperature, but at this temperature, matter changes from liquid state to gas state. A very important thing to know is that the melting point and boiling point for each matter is different. What do we mean by that? Let's take a look at water, for example. Ice has a melting point of 0. So once ice reaches 0 degrees, it becomes liquid, because this is the melting point, or it starts to become liquid. The boiling point of water is 100 degrees. But let's take a look at another liquid, which is mercury. Mercury has a boiling point of 357 degrees. So it starts to change its state from liquid to gas at a much higher temperature than that of water. So each matter has its own melting and boiling points. Okay, let's try answer these questions. So first, the melting point is the temperature at which a solid matter changes to gas. Is that true or false? That's definitely false. Why? Because melting point is the temperature at which solid changes to liquid, not gas. Well, mercury has a boiling point of 100 degrees Celsius. Well, so that's definitely wrong. It's 357 degrees Celsius. Another very important thing we need to talk about is something called thermal expansion. Remember when we were talking about muscles, right? And we know that muscles contract and expand. So what is the meaning of expand or expansion? For something to expand, this means that this object or this thing increases its size. So when the size of anything increases, this means that this expands. And a very important thing to know about matter is that matter can change its size as well. So matter contracts and expands according to the temperature. How? When we cool something, this means when we decrease the thermal energy of anything, matter contracts. So the size becomes smaller. But when we heat something, it expands. So the size becomes larger. Of course, this change in size cannot be really seen sometimes, especially when we're talking about solids, but it's a very important thing to know because we will see how it can be very dangerous later in this video. A very good example about expansion and contraction of matter is the thermometer. The thermometer has a liquid inside of it, and this liquid could be alcohol sometimes, or it can be mercury, molten or like liquid mercury, because mercury in its natural state is liquid. So, but most of the thermometers we use, it has alcohol, not mercury. So this liquid, it has a specific red color to be seen, and when you put the thermometer in cold water, you see that it's at a low point, and when you put it, the same thermometer, you put it in a hot water, you see the alcohol rising. So this means it expands and contracts. Its size increases and it decreases. So this change in size is due to the change in thermal energy. Another very, very important usage of thermal energy is jars. Sometimes you take a jar with a metal lid, with a metal cover, and when you take it out of the fridge, you try to open it, and it doesn't open easily, right? So maybe you can ask someone older, or maybe you can try to use something, like use a piece of cloth or something. But a very important thing to know is that if you add hot water on top of the cover or on top of the lid, it will expand and you can open it easily this time. So this is something we can learn about uh, how matters expand and contract, and we can use it for our own good. A very important thing as well is for matter expansion is bridges. When you are riding a car on a bridge, you can see these joints here, these things connecting the bridge together. But why do we make them? Why not make the whole bridge out of one piece? Well, these joints are made of steel, and it's a metal, and these joints expand when it's hot. So they fill up these spaces here, and this protects the bridge from buckling or bending. Bending means that the bridge becomes bent like this. Let's draw it here. So this is a straight line, like this is a straight bridge, but when it becomes bent, it becomes like this. So, of course, this is not good for a bridge, because it can be damaged, it can fall down. So this is very dangerous, and that's why we use these metal joints in bridges. Let's try and answer these questions now. Contraction happens when the temperature decreases. Is that true or false? Well, that's true. So contraction happens when the temperature decreases, and expansion happens when it increases. Next, expansion joints allow bridges to expand safely. That's true as well. Good. In this lesson, we are talking about an experiment of how to make a thermometer. So we saw that a thermometer is something that tells us the temperature, right? So for this experiment, you need a plastic bottle that contains 50 milliliter of alcohol and 50 milliliter of water. We need a plastic straw. We need a bowl containing hot water and another containing cold water. We need an eyedropper that contains a red dye, and we need clay. So first, we are going to add a few drops of the red dye into the plastic bottle, and we can make it look red. Then we put the straw inside the bottle and we fix it using the clay, as you can see in this figure. Once you add the straw, you can see the liquid going inside of it. Now we try our experiment. So this is our thermometer. This is our thermometer. So when you put the thermometer in hot water, you see the liquid, the red dye, rising upward. When you put it in cold water, you can see it going down. So here it expands and here it contracts. Why? So this is the conclusion. Expansion happens when the temperature is higher. This is the case for hot water. And contraction happens in the case of the cold water. Very good. So how do we increase the thermal energy? By heating or by moving matter. Because when you move something, the kinetic energy increases. And then, as the kinetic energy increases, because thermal energy is the sum of the kinetic energy, as the kinetic energy increases, the thermal energy increases as well. So let's try and answer these questions. When the thermal energy increases, the kinetic energy of the molecules, what happens to it? The kinetic energy of the molecules increases. And the particles, the molecules, they move faster. Now, the spaces between molecules of a matter, what happens to the spaces? The spaces expand. So the what of matter will rise, the temperature will rise, and this matter will rise upwards. Okay? So this is the answer to this question. Finally, we try and see more uses of thermal expansion. We already talked about the expansion joints, and a very similar idea is the railroad tracks. Inside the railroad tracks, you can find tiny spaces between the railroad tracks. This as well is used to protect the railroad tracks from bending or buckling due to expansion, because in hot summer days, in the hot weather, matter expands due to the increase of the thermal energy. So this could lead to the expansion or buckling of matter. So this way, when you add the spaces in between the railroad tracks, you can protect, because this gives the space for matter to expand, and this way you protect the railroad tracks from bending or buckling. Let's try and answer these questions now. Engineers use expansion joints to keep bridges safe from expansion in cold weather. Is that true or false? Well, that's false, because expansion happens in hot weather, not the cold one. Now, number 2, to avoid train accidents, engineers leave small spaces between the railroad tracks to avoid bending the tracks. Is that true or false? That's definitely true. Good. Now we have finished concept 1 and theme 2. Hopefully you understood everything, and if you have any question, you can always use the website or ask your teacher for help. And finally, wishing you the best of luck, and I will see you in the next video.